Okay, guys. So, for those of you guys that missed the lesson on Friday, or might have not caught it on, or might have just gotten to a little trouble over the weekend and couldn't figure this out. Okay, so we are going to graph a piecewise function. This is the example that we didn't get to on Friday. Excuse me. All right, so this is graphing a piecewise function. So the first piece is the function f of x, and we all know what f of x is. So it's the same as y. So it's f of x equals negative x minus 9. Okay, and we're only going to graph that in the domain, or basically this is like a restriction for x that is less than or equal to negative 3. Okay, so basically we kind of want to graph it on this side of negative 3. So here's negative 3. So we want everything on the left side of x equals negative 3. And that's kind of like the dividing line. Okay, so we want to graph this line or function or whatever. In this case, this is going to be a line. So this is going to be negative x minus 9. And if you're not sure about how this graph looks like, go ahead and put on Desmos. If you're good, then you can go ahead and graph it just by looking at this. All right, so you guys are well past this, but this is in the form of y equals mx plus b. All right, so this is in slope-intercept form, which means that I'm going to start graphing at the negative 9, which is down here. And then the slope is negative 1, because that's the b right here, or the m. So it's going to be down 1 over 1, so down 1 over 1, and that's the next point. Right? And if I keep going, it's going to go down below that. So I have to go backwards, and if you just kind of connect those two dots, you'll see that it's here, here, and I'm just going to make a couple dots, here, 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 here. So it's just that diagonal line, right? And I'm just going to draw my line through there. So over here, there'll be a diagonal line going down there. Okay. And it's going to continue on going down there. Okay. So that's the graph of f of x equals negative x minus 9. It's this one down here in red. Okay. Again, we only want that for x less than or equal to negative 3. So that means that anything that's bigger than negative 3, so bigger is on this side here. This over here, they're all bigger. Okay, over here, it's less than. Right, so we only want stuff that's going to be less than. So anything that's bigger, we're going to erase. Okay, and all of those are going to get erased as well because they're all bigger than negative 3. Okay, and we really just want everything that's on the left side of negative 3. And we actually just want negative 3 as well because it does have that little underline. So that means that we do want that negative 3. So I'm going to go ahead and just, well, you get what I'm saying. So I'm going to go ahead and just redraw this out so it looks a little nicer. Well, that was actually pretty bad, but you get the idea, right? So that's x is less than or equal to negative 3 for this function here, okay? So once we're done with that, we're going to move on to the next function. Okay, and the next function is, and I'm going to use a different color. Next function, I'm going to use blue on this one. And it's a function f of x equals negative x squared plus 3, okay? And we're going to use that in the domain, or the restriction is going to be between negative 3 and negative 2, right? So I'm going to go ahead and show my restriction. So between negative 3, so I want it between here and positive 2. So I'm going to go ahead and draw another line, just going to help me with the drawing. Okay, not the best line, and I'm going to erase this later on anyways. Okay, so I'm going to go ahead and figure out how to graph negative x squared plus 3. Okay, if you're not sure, put on Desmos, put on a graphing calculator. Okay. But if you're pretty good, because you have been through Math 1, Math 2, and Math 3, you can know that this is going to be an upside down parabola from the negative x squared. And then the plus 3 is going to be where it's going to be on the y-intercept. So it's going to be right here. And then it's going to be negative x squared, meaning it's an upside down parabola. Parabolas, normal parabolas, it's going to go out 1 and then down 1. This is going to be upside down, remember? It's out 1, down 1. Okay, and then out 2 and then down 4. So right there. Out 2 and then down 4. Right there. Out 3 and then down 9. So this one I'm going to count. It's not too easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. hit that spot. And then 9, so out 3, so 1, 2, 3, and then down 9, and so forth. And it's going to keep going from there, right? So this parabola is going to do something like this. It's going to keep going, like that, down below there. And this one's going to keep going as well over here. Okay. Again, remember, we only want it between -3 and 2, because this is x is greater than -3, so greater is everything on the right side of -3, and then less than 2 means everything on the left side. So again, we only want the stuff that's in between these two. So again, I'm going to erase everything that's on the left side of -3, because we want greater than. So that this is everything greater than -3. And then we also want everything less than 2, which means that everything that's on the left side of 2, we want that. And we don't want anything on the right side of 2. Okay. So again, I'm just going to go ahead and fix a couple of these dots just to make sure it looks nice for you guys. All right. Okay, so that's the second function. Okay, and the last function I'm going to use, I don't know, I'll use purple, right? All right, so last function is f of x equals -1. And the restriction on the domain is going to be x is greater than or equal to 2, right? So my function f of x equals -1, if you are well versed in graphing, you would know that that's going to be a horizontal line at y equals -1. So basically it's going to be this line over here, right here, all of this. It's going to keep going in that direction. Okay. Again, so that's f of x equals -1. If you're not sure, put it on decimal so you see it's a horizontal line going across. Right? And then our domain, our restriction, however you want to call it, our domain is going to be x is bigger than 2. Right? And again, here's 2 on the x. So again, we're done with this one over here. So I'm going to erase that. But anything bigger than 2, that's what we want. So here's the x equals 2. We only want the stuff that's bigger. So we want that stuff that's over here. So anything on this side, we don't want. Oops. All right. And that's pretty much it. So that's the graph of the piecewise function. I'm going to go ahead and erase this x equals 2 just to kind of tidy it up a little bit, but it looks kind of like a little heartbeat. All right. So that's our graphing piecewise function. This is a 3-piece piecewise function.